In this video, we're going over determining whether a function is even, odd, or neither. So here are some definitions for even and odd functions. So the even definition says for a value, f of negative x is always going to be equal to f of x. And then an odd function, that definition says f of negative x is going to be equal to the opposite of f of x. So if a function does not satisfy either of these two definitions, then we're going to say that it's neither. Okay, so to take a look at some examples here, if I take a look at this first example of a graph, I'm going to pick an x value. So let's say x equals 2. So if I look at the even definition, that would say f of negative 2 has to be equal to f of 2. So remember, the number inside parentheses is an x value. So when x is negative 2, that y value looks like it's like barely below 0. It's negative, very small number. So maybe negative 0.1. Okay, that has to be equal to f of positive 2. So when x is positive 2, the y value is a very small but positive number, so maybe 0.1. These are definitely not equal. Therefore, this is not an even function. Let's check if it's odd instead. All right, I'm going to erase since there's not a whole lot of room there. I'm going to stick with that same x value, x of 2, but looking at the odd definition, if it's odd, f of negative 2, the x value that I picked, has to be equal to the opposite of f of 2. Okay, so if I look at the function where x is negative 2, again, that was like negative 0.1. Now I'm going to put an extra set of parentheses in here because we're evaluating f of positive 2 and then we're changing the sign of it to negative. So f of positive 2, remember, was positive 0.1. And the opposite of positive 0.1 is negative 0.1. So this satisfies the odd definition. So this function right here is odd. Also, a way that you can tell even and odd functions are by the visual representation. So notice it says an odd function if the graph is symmetrical with respect to the origin, which worded another way means that you could rotate 180 degrees around the origin and the graphs would match up. So notice if I were to take this graph and rotate it 180 degrees. 180 degrees is a straight line. So rotating it, so basically the bottom part of that y-axis is coming up to the top. That would also mean this x-axis, right, is going around here. Okay, if you take that function, that blue line, and rotate it that 180 degrees, it is going to fall right on top of that other piece of the function. So that, again, verifies that this is an odd function. Okay, second example, I'm going to stick with an x value of 2, I think, looking at this graph. Again, I'm going back to even definition, which says f of negative, my x value is 2, should be equal to f of 2 if it's even. Okay, so if I evaluate x, when x is negative 2, it looks like the y value is 10. And when I evaluate an x value of positive 2, the y value looks like it's still 10. So this one satisfied the even definition. So this is an even function. How you can tell an even function visually is that it's symmetrical across the y-axis. So if I were to make a fold in my graph right on the y-axis, the left side is supposed to match up with the right side of the graph. And again, that's for an even function. Okay, so some people find it easier to use the definitions. Some people find it easier to do the visual representation. So, whichever way you feel like is more comfortable for you is fine. Okay, so this first one, I'm going to use the visual representations. If I were to fold, excuse me, if I were to fold the graph right here on the y-axis, notice that the left side is not going to match up to the right side of the equation. And then if I were to rotate this graph around the origin 180 degrees, the graph is not going to fall right on top of itself. So this is neither. Guys, if this looks like a quadratic function. So if this was a parabola that was that vertex was on the y-axis, then it would be an even function. I could fold it so that the left half would match up with the right half. But the fact that this has been moved, it looks like left one throws off that even and odd nature. So we would say that it's neither. Okay, a similar thing happens with number 2. If I were to fold on the y-axis, the left side is not going to match up the right side. And if I look at the origin and I rotate that 180 degrees, it's not going to match up with itself. So this is, again, neither the way it is right now. But if I were to shift this graph up so that that point would line up on the origin, now it would be odd, because then I could rotate it 180 degrees and the left side would match up with the right side. So again, the way that it is right now, it's neither. However, it would be odd if we were to take that shift away and shift it back up to the origin. Okay, looking at number 3. If I were to fold on that y-axis right here, the left side is not going to match up the right side. So it's not an even function. However, if I were to rotate this graph about the origin 180 degrees, so if I were to take that x-axis and rotate it over here, too far, just to 180 degrees, which is a straight line, the left side would match up with the right side. So therefore, this is an odd function. All right, number 4. Again, the way that it is right now is going to be neither. If I were to fold on that y-axis, the left side is not going to match up the right. And if I were to rotate that around the origin, it is not odd as well. So that left-hand side would not match up the right-hand side. Without the shift up, so it looks like it's been shifted up like maybe 3 units. If I were to shift that down 3 units, it would be odd around the origin. But the way that that's graphed right now, this is another neither.